Okay, this is my second video for my pre-calculus class for my Law of Sines and Cosines Lab 2, where we're doing word problems. So I'm going to help you read the problems, try to help you draw the picture so that you can come up with the answer. So I have these two lighthouses. They're 12 miles apart along a straight shore. A ship is 15 miles from one lighthouse and 20 miles from the other lighthouse. Find to the nearest degree the measure of the angle between the lights of sign from the ship to each lighthouse. Okay, so let's draw this. There's two lighthouses, so let's do a straight shore right here. So here is our shore, and we're going to make them 12 miles apart. So here is one lighthouse. Okay, so here's a lighthouse here, and we'll do a lighthouse here. Okay, and they're 12 miles apart, so I'm going to do it right here. So it's right on the water. A ship that is 15 miles from one lighthouse, and 20 miles from another. So let's kind of do 20 miles here. So here's our ship. And so this one, they're out on the water. Okay, so they're on the land here, and this is all water. And here's my ship. And this is 20 miles here. And this one's 15 miles. Okay, and here's my ship out on the water. So this is all water out here. Okay, so now we're looking at, okay, we want to know what the angle is between the ship and each lighthouse. So basically, we're looking for this angle here. All right, so you could call this ABC if you want. You got A, B, and this is C. So we're looking for basically angle C. Okay, so if we're looking for angle C, all right, and they said, oh, wait a minute, I didn't write down how far apart they are. They're 12 miles apart. Okay, so they're on the green land here. So I'm looking for angle C. Angle C is opposite that, and I only have one angle, so I have to use the law of cosines, which we've been using on this lab quite a bit. So I'm going to use 12 squared. So that's going to be C squared is going to equal the other two sides squared, which is 15 squared plus 20 squared, minus 2, repeat, 15 times 20, cosine of angle C. So this one's a little bit different because you're looking for the cosine of that angle. Now, the one thing I want you to remember is you cannot just put all these numbers in your calculator because this is a term, this is a term, and this is a term here. So what I want you to do, first of all, is move those over there, okay? So you're going to do 12 squared minus 15 squared minus 20 squared. And then you can actually put these in your calculator, negative 2 times 15 times 20. That's going to equal negative 600 cosine C, because then that way you won't make the mistake thinking that you can put all those in your calculator at once, because you can't. Now, when I put all these in my calculator here, I get negative 481 equals negative 600 cosine C. All right, so we're looking for the angle. So now I'm going to divide by negative 600. So when I do that, I get cosine of C comes out positive as a 0.8016667. And then in order to find the angle, you have to do inverse cosine on both sides. Don't forget that, because I don't really care about the cosine of C. I want C. So C comes out to be, and they said to the nearest degree, 37 degrees. So this comes out to be 37 degrees. So this one's a good one. I would star this because it's one where you're using the law of cosines to actually find the angle. This one's a little bit trickier than the other ones we've done previously. Okay, let's look at number 5. A tree, whoops, I hit it with my arm. I'm sorry. I hate it when I do that. A tree is braced by wires 4.2 feet and 4.7 feet long that are fastened to the tree at the same point and to the ground at 7.8 feet apart. So you're like, how do I draw this? Okay, so let's try that again. It's braced by wires. They tell us how long they are. They're fastened to the tree at the same point. So they're at the same spot on the tree and to the ground where they're 7.8 feet apart. Notice I did not say on the same side. So if you think about bracing something, it's usually on opposite sides. So I just want you to know that when you're doing the picture. So I'm going to do a wire here, a wire here. This is going to be my tree. Okay, and here we go. So here I have a wire. They said one is 4.2 feet long. Here's my other wire that's 4.7 feet long. And they're fastened to the tree at the same point. So that's right here. And on the ground, they're 7.8 feet apart. Okay, so they're fastened right here and here, and this is 7.8 feet apart. So this is a wire. Let's just do this. Okay, and this is our ground. So maybe this will help you see it a little bit better. Now, they want us here to find to the nearest degree the measure of the angle between the wires at the tree. So again here, so here's our ground. So I'm going to say this is green right here, green ground right here. They're looking for this angle right here. All right. So again, label this picture to help you out. A, B, C. So they're really looking for angle B. So if this is little b, remember, if this is the law of cosines, because I don't have enough for the law of sines, I'm going to do b squared equals the other two sides squared. So I'm going to see if I can find a spot here. So we got 7.8 feet squared. That's b squared equals the other two sides squared. 4.2 squared plus 4.7 squared minus 2 times 4.2 times 4.7 and cosine of b. Again, this is just like the one before, so you can start this one too. Get those over to the other side first, and then put these together on that side. So I'm going to say 7.8 squared minus 4.2 squared. Get them over there so you don't make that mistake. Equals, and then when I put those three in my calculator, I get negative 39.48 cosine b on that side, okay? Then I'm going to put all these three together. When I do that, I get 21.11 equals negative 39.48 cosine b. Divide by the negative, I get cosine of b to equal negative 0.534701. And then you're going to have to hit inverse cosine on both sides. Thanks for playing. So angle B comes out to be, they said to the nearest degree, 122 degrees. So here it is 122 degrees. Okay. So there's another one where we found the angle. So 4 and 5 are alike. That's cool. And notice we've used the law of cosines a lot. And I did this on purpose because I tend to use law of sines if I can over the law of cosines, but really it comes in handy and it's good practice. Last one for this video is number 6, is a telephone pole on a hillside. So they gave us a picture on this one. Makes an angle of 78 degrees with the upward slope. So that's right here. A wire from the top of the pole to a point on the hill is 12 feet long. So let's label this as we go along. So this is 12 feet long. That's our wire, okay? And it makes an angle of 15 degrees with the pole. So the 15 degrees, this is kind of skinny, so I'm going to just put an arrow. That's 15 degrees in there, right in there, okay? And it looks little. This is 12 feet. It says angle 15 degrees with the pole. Sorry. A, find to the nearest hundredth, so that's 2 decimal places, the distance from the foot of the pole to the point at which the wire is fastened to the ground. So basically, we're looking for x right here. So we're looking for this distance here. So I look at what I have, and I say, okay, there's a couple things I know. One is I have an angle here, and I don't know, but I have an angle here, and I do know what that side is. So I'm going to do that. So let's do A. So I'm going to do 12. I can do the law of sines as to the sine of 78 degrees. Equals, I'm going to try to find x, which is that length, as the sine of 15. So here, because I had an angle opposite a side of length of my triangle, I can use the law of sines. So when I cross multiply, I have x times the sine of 78 degrees equals 12 times the sine of 15 degrees. Then divide by the sine of 78, I get x is 12 times the sine of 15 degrees divided by the sine of 78 degrees. And when I do that, I get it to be and they said hundredths, 18 feet. So this is what this is, 3.18 feet right here at the bottom of the pole to the wire. So that's cool. We just answered A. Now the B part says, use the answer in part A to find to the nearest tenth the height of the pole. So we're going to use this to the nearest. So I'm thinking, oh, they're going to let me use this. And guess what I have across from there? 15 degrees. So I can do the law of sines again, because they want me to find the height of the pole. So now I'm looking for this. We'll call this y. We're looking for the height of that. So, but I'm like, wait a minute. I can do this is to this, but I don't know this angle. But do we? Of course we do. If this is 78 and this is 15, if I add them up and subtract them from 180, this angle right here is so skinny you can hardly see it. It's 87 degrees. So guess what I can do? For the B part, I can say, all right, 3.18 feet is to the sine of 15, because they said to use that, so I did. All right, is the same as y, which is our pole, is to the sine of 87 degrees. So this is a cool one. I could use the law of sines twice. Now, when I cross multiply, I get y is going to be 3.18. I'm skipping a step, sine of 87 degrees divided by, okay, sine of 15 degrees. So if this bothers you, put the step in between. So y comes out to be, they said to the nearest tenth this time, 12.3, because it said nearest tenth right here, 12.3 feet. So that's the height of the pole right here. Okay, that's cool. I got 3 more on this one, so I hope this helps.